Hi guys, I'm back with part 2 of the Double Dragon Arcade PCB repair. This is this time you do the repair video series. For every one of you that missed out on the first video, I highly urge you to look at that before you continue on any further. And for everybody else here, I have the top voted next steps for this repair for you. So most of you were suggesting to check the CPU, clean up the PCB and look at corrosion, check the clock signals, look at the voltages mainly at the CPU, do a ROM check maybe, and also explicitly check the sync signal that is coming out of the PCB. So I think these are really good suggestions. In this video I will now actually follow those proposed steps, and after that give you an update on my view on the general situation we are at, and I will again accept your suggestions how to continue with the repair, and we will do so again and again until we fix the board. So, but enough talk, let's get right into it.
Okay, so first of all, I'm going to clean up this PCB. I just removed all the socketed ICs from this top PCB and put them aside next to the PCB, and actually in the order that they are situated on the PCB, so I don't switch any of them around when I'm repopulating the board later. And maybe I will also take the opportunity to, if those chips, if I have them outside of the board, I can also check them in my EEPROM reader, if all the EEPROM's contents are okay. Those 4 EEPROMs here are containing program code for the main CPU of the game, which is this guy here. This information can all be derived from the schematics actually. And we have another CPU over here for the sound. This has 2 EEPROMs here which contain digital sounds. And this EEPROM here, which is this one, contains the program code for the sound CPU. And this EEPROM here is actually containing some graphical data. I think you know, the text layer, so the display layer of the game, the characters of text and so on are located on this EEPROM. So at least I should check those 4, and this one here, which contain the program code and which are actually required to run the game. So, but now first of all, I'm going to clean up this PCB.
Okay, so after cleaning, this PCB turned out pretty nice. I was just using water actually to rinse it off, and dried it off with a blow dryer after that, so looks perfect. And you know, looking at the spots on the bottom PCB on the solder side that we saw before, the spots of corrosion, or the one border of the board that did look had some problematic spots, under the microscope and also just by plain vision, you can see that the IC legs and the wire points seem to have some minor degree of superficial corrosion left on them, but I think the traces are all intact. I don't really think that there is too much of an issue here that we should be actually worried about.
Okay guys, so I tested the program EEPROMs for the main CPU and the sound CPU in my EEPROM reader, and compared the red data to the main database, and they actually turn out to be okay. Okay, so after cleaning the PCB, checking the EEPROMs and cleaning the EEPROM chips as well, I put everything back together and just hooked it up for another test, but yeah, it actually shows the same that it showed before, so no change after cleaning and after reseating the EEPROM chips. Okay, so next thing I did, I actually measured the voltage on the main processor, so that we are sure that the voltage is actually present, and it turned out to be 5.1 volts, so that's perfect actually. Well, I hooked up my logic probe, and I would suggest that we actually now check the pins of the main CPU and see what the CPU is doing. So looking at the schematics, we can see that the address lines are starting at pin 8 and are reaching through continuously to pin 23. So 16 lines address bus. This is a 63C09E CPU, which is a Hitachi version of the 6809. It's pin and operation code compatible. Okay, so let's check the address lines. 1, 2, 3, 4, 5, 6, 7, 8. This is where the address lines begin. First address line is address line 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so the address lines appear to be all wiggling. Following that directly is the data lines. Pins 24 through to 31. So we start here. This is 24. Yeah, 21, 22, 24. So this is D0, D1, D2, D3, D4, D5, D6. D7. I did this right. Did I? 7, 6, 5, 4, 3, 2, 1, 0. Right. 1, 2, 3, 4, 5, 6, 7. Okay, so all wiggling as well. And we have the pin after that, 32, is read-write line. So this is toggling also, which is good. We have on pin 1, we have ground. On pin 7, 1, 2, 3, 4, 5, 6, 7, we have plus 5 volts. That is correct. That's what I just measured also with the multimeter. Okay, and what else do we have? Clock, very important. Clock signals. 2 clock inputs, E and Q, like on the 6809. They are, in the schematics, they are here. They are at pins 34 and 35. So we look at them. 40, 39, 38, 37, 36, 35. Okay, toggling clock here. 34, toggling clock also here. Okay, we have the clock. What else do we need? We need the reset, which is this guy over here is 33. So we have 40, 39, 39, 37. This is it's 37, right? Yeah, excuse me, 37. So, and this is high, which means that reset is permanently high. So the CPU can run. And last but not least, the last thing we are seeing here is interrupts. 3 interrupt lines going into the CPU on pins 2, 4 and 3. So the NMI is pin 2. This is toggling. Yeah, this is normal behavior if the game is running, actually, I would say. If the game would be running, rather to say. Pin 3 is permanently high. This is the IRQ input, and which is also okay. At least the CPU isn't halted this way. And we have pin 4, which is the FIRQ, which is also toggling. Okay, so looking at with the multimeter and the logic probe at the CPU, actually does not reveal any problems, I would say. You could actually say or imagine that this CPU is running, probably. A very interesting thing I just noticed, you know, without actually doing anything to the board, there is a slight difference now in the appearance of the screen. You know, there's still the light gray screen, but there's some, you know, like yellowish lines have appeared around here. So a slight difference in the video output, and there's something glitching around here. I don't really know what to make of that, but still no other response coming from the board. Okay, and if you check the clock signal of the CPU with the oscilloscope, this is how it looks like. This is a 3 MHz clock signal, I would say. So no obvious problems with that. They are actually this kind of signal is present on both clock inputs E and Q, which is how it is supposed to work, actually, I think, for this CPU. Okay, also checking on the oscilloscope, I have the sync signal here. I just grabbed it from the jammer connector. It's on, you know, pin 13 on the solder side, and it looks like this. Has 15.6 kilohertz. That is the line frequency, actually. In 1 second. Yeah, okay, here you can see it. We have a picture rate of 57 Hertz, which is like NTSC. So this sync signal is actually also quite in order.
Okay, so these were the results of the next diagnostic steps that you requested. So what do you make of the situation? It gets a little more interesting now, or maybe a little more difficult. What would you suggest that we do next? Well, what is my view on the situation? Well, I didn't really expect that the CPU would have so much activity going on, actually. As far as I can tell, there seems to be maybe even a working CPU process on this PCB running, with all the interrupt lines and everything toggling. So maybe we even have just the problem that the game is playing blind somehow, meaning that there's just a video output issue. But on the other hand, I don't know, why don't we get any you know, response from coin inputs and control inputs, like with sounds or anything, if the game would only be running blind? Or is there maybe actually an additional sound problem as well? Well, I don't know. What do you make of the situation, and what do you suggest that we could do next? I'm very curious, and so again, please leave your comments, and I will look at all of your suggestions that you make in part 3 of this video series, which is coming very soon. So thanks for watching, and see you in the next video.